Alright, time for another NONAMé Box Mods build video. What do we got today? Well, we're going to be building the Dual-MOSFET PCB. So this is the updated version of the kit. This is really easy build. I can already tell I left the wrong part in there, but let's go over it. Get a little advertising here. This kit comes standard with a 1590G. That's the palm-sized box. So that's what we'll be building in today. There's some heat shrink tubing. This particular kit has the dual 18650 battery holder. It's a Keystone sled. It's nylon. It's a pretty nice sled. It comes with 4 nickel magnets, a black button. This is a black raised button. This is actually plastic, but I've found these hold up a lot longer than the more expensive metal ones, so I'm probably going to stick with those. Let's see, what else do we got here? Got a 510 connector. This is the low profile stainless steel 510 connector from Fat Daddy Vapes. Guess I could throw one of their logos in here. So there we go. Now you get the video. Let's see, what else? So this is the V4. It's my understanding they'll be coming out with a V5 soon if they haven't already. But this is a nice little shorty 510 connector, works pretty good. There's some more heat shrink tubing. We also have fuses that I lost. There we go. 2 15 amp resettable fuses. These are tiny little bastards. Just to give you an idea, very small. Put those in there, and we got 4 grub screws. Those go in the screw holes of the box, and that's what the magnets connect to. And last but not least, we have the MOSFET board. As you can see, this is very tiny, and after much debate, I decided to sell these boards assembled because I didn't think it was very reasonable for people to solder these SMD components on there themselves. So this comes all assembled. I had a few calls now saying that I forgot the MOSFETs. No, that's what these little black things are. And the resistor is the very tiny thing right there. And then we have the selector switch for lockout and voltmeter. So that is the whole board. And that's the kit. So today for the kit, I'm going to swap out a couple of these parts and swap out the magnets for these black ones. And I'm going to swap out the box for this custom powder coated green circle one with the smoked overlay. And for the 510 connector, I'm going to throw this green one on there instead. And those are all extra options on the site. So you can get the standard kit and it's pretty cheap, or you can spruce it up a bit and have something a little bit more unique. So we're going to get started with drilling, and hopefully I can get this whole video in under an hour. I'm thinking maybe faster. Alright, let's talk tools real quick. So we got hand drill. I'm going to do most of the work with this, although I do use my drill press for doing the magnet holes in the lid. Dremel. I use this to shape the battery sled. Should use my words here. This is just a metal burr, good for grinding off the plastic real quick. As far as drill bits, since we're not doing a voltmeter on this one, this step drill bit is a pretty good job for it. We only need to drill 2 big holes, so this is perfect. And the 1/4 inch bit for the magnets. And that's about it. Otherwise, another very helpful tool is something like this vise. So it's just a cheap bench drill vise. I don't know, I got it for like 25 bucks at Home Depot. It's bolted to a piece of MDF and I can move it off my workspace when I need to. So I got kind of dual usage of everything here. So that's about it for tools. Next I'm going to go into getting this box drilled out and we can start on the soldering. Alright, quick shout out to BX Vapor. I've been religiously vaping their horchata for, I don't know, past month or so. Really love this stuff, so I figured they deserved it. So let's see here. We got our box and we need to put holes in it. Knowing where to put the holes is pretty important. So I have created these handy dandy cutout drilling diagrams. And all you need to do is cut out, I should really talk about printing first, I guess. Do not print this from your browser. It will screw up the margins and it'll like compact it and change the scale and everything. So don't do that. Open up the PDF in like Adobe Acrobat or something else. Preview if you got a Mac. And print it out from there. No margins, anything like that. And then when you print it out, this should be 1 inch by 1 inch. And just check the scale and make sure everything's right. Other than that, the only real trick to these is cutting out the diagram. You want to cut outside the line. You do not want to cut on the line, you want to cut outside of it. The program that I use, the lines are part of the dimensions. So just make sure you trim it up as close as you can. Using a ruler and an X-Acto knife probably isn't a bad idea. You also have your options for right-handed and wrong-handed, for those people out there that like that. And I put 3 different options for where to place the 510 connector. For this small 1590G box, I strongly suggest that you place it opposite of the button. It's a pretty small box and the battery sled is going to get in the way of a lot of things. So for the right-handed version, it's going to go on this side of the box. So the button's going to be about here, and then I suggest putting the 510 connector over here. And that'll leave room for things to snake around. So after you cut all that out, I have templates made, so I don't have to do that anymore. Let's see. Thing I forgot to mention always in the tools is hammer and punch. This makes everything incredibly easier. But I just take my templates and the thing to note about these is there are these vertical lines near the sides, and those actually line up with the screw posts on the inside. Because these edges are curved, it's kind of hard to get something to line up with it. So when you line them up, just make sure those dashed lines are right with the screw posts, and it'll get it in the exact right place. You also notice that this center line is offset. That is to account for the thickness of the lid. So you want the skinnier side on the opening where the box is. So just keep that in mind. So getting these marked, I just have one of these printed out here, and I will punch it. And then I have another one, just a little cutout. Looks like good mark. Didn't mess anything up there. So the 510 connector is 7/16 on this step drill bit, and the button is 1/2 inch. One thing I want to note about these black buttons compared to the chrome button is they have a little bit of a lip right here for locking it in place or whatever. I don't know if the camera can see that, but right there around the inside. So we're just going to over drill a little bit to account for that. It doesn't look that great, but it works. So we'll get this sandwiched in the vise here. as always, if you're working with power tools, safety glasses. For this stuff, I really prefer the hand drill. One of the main reasons is actually because of the patented Hammond lean. These boxes are drafted so they can come out of the mold. And if you try to hold it under a drill press, it's going to go straight down when this face is actually canted to the side a little bit, both because of the draft on this face and on the bottom. So I think doing it with a hand drill is a better option all around. Alright, so I intentionally over drilled a little bit there. There's a little lip. That'll be fine for the button. And we're going to take that out and brush all those chips off the nice powder coat. Get this stuff out of here. And we'll do the 510 connector, which again is 7/16 of an inch. It's just a little bit bigger than you need it to be. Some people have asked me questions about that before. I find the extra wiggle room doesn't matter too much. The 510 connectors are supposed to be 10 millimeters, and I forget exactly what that is in inches. But the little extra wiggle room lets you align it a little bit easier. So a little over drill again, but it doesn't matter because the 510 connector will cover it up. And that is the box drilling portion. The only thing left to do is to drill out the magnet holes, which I'm going to pause the camera and rotate it here. Alright, so we got the 1/4 inch bit in the drill press, and what we're going to do is drill out the holes in the lid so they go almost all the way through, but not quite. We want the metal to retain the magnet just a little bit. So I'm going to do that real quick. Alright, so you can see it's not quite to size. It's not all the way through, but it doesn't go most of the way through. And what that'll allow us to do is fit that magnet in there flush. So I just keep magnets on my drill press to test these when I drill them out. I'm going to repeat this process here real quick for the other three. I have had questions before of, why don't you drill them from the bottom and press fit them? The holes in these are sloped for the screws. They're flathead screws, so like this. So they are sloped, so that fits in there flat. And if you drill out from the other side, you're going to meet that conical shape there, and there's not going to be much to hold the magnet in. So I think this is much better. I don't know, it's debatable if it looks nicer or not, but when you think about the force of the magnets are pulling when they're getting removed, it's better to have the stopper on this side, on the inside, if you ask me. So I'm going to do those other ones real quick. off all that crap, do a quick test fit. That one still needs some. That one's good. That one's pretty good. Now I used to have a drill stop, so I had only drilled so far on this, but it broke. So now I just do it by hand. So that is the magnet holes drilled, and that is pretty much all the metal working we need to do. There might be a little bit at the end, trimming off some of this lip, but that's about it. By the way, the box I'm using is the SX350J with the dual 18650s that I built in one of the previous videos. Thing seriously kicks butt. Alright, let's talk soldering tools. Bare minimum, soldering iron, of course. Solder. I use rosin core, and I also use flux in addition to that, which some people debate, but whatever. I really like to have little pliers like this. The bent ones are particularly useful for jiggling parts around and such. Wire cutters, not entirely necessary, but very helpful. Wire strippers, definitely necessary. These also have cutters built in, but they can't get into the places that these can. For wire, we're using 22 gauge for the little logic wires. That includes the button and the extra positive wire to power the board, and then 16 gauge for the main load stuff, red and black. You might see this here. This is El Squido. This is essentially a third hand tool, but with 6 hands. This is again one of the MDF boards that I have that I swap out. The camera did not move here. I just swapped the board out, and this holds stuff while I solder it. As for the actual soldering iron I use, that is over to the side here. That would be this FX 888D from Hacko. It's a digitally temp controlled soldering iron. It's expensive. It's about 90 some bucks on Amazon, I think. But I use it every day, and it is an awesome, very awesome soldering iron. And if you haven't read the instructions and you have one of these, always keep a little bit of solder on the tip of that. Otherwise the temp control goes wonky. Alright, so that is tools. I'm going to start getting wired up with the MOSFET board here and getting the necessary parts attached to it. And we'll take a short break to do the battery sled modification, and I'll start putting it all together. Okay, so the way I make these boards, and I do actually make these boards myself, I solder all the parts on with a reflow oven that you can see in another video, but you'll notice that there are some bare copper right here and here, and these are the major load points between the MOSFETs. So when we solder wires onto these, we're going to pull up extra solder here just to make sure it has essentially enough gauge to make a good electrical connection here. So we can see this is the bat negative. This goes to the battery pole on the negative, or negative pole on the battery sled. And this one here at the end goes to the 510 connector negative. As far as the logic goes, there is also this spot back here for the positive connection that switches the gate for these MOSFETs. And that'll get wired to the positive on the batteries. And what the alligator clip is covering up here, the 2 spots for the voltmeter, if you get the voltmeter option. And that would be one of these doodads. And you can wire that straight into the board. And what's nice about all that is this 3-position switch here. So when it's in this far position all the way to the left, the MOSFET board can't fire. It's in lockout mode. It doesn't mean the power is cut, but it can't fire, which is the important part. In the second position, it can fire, but the voltmeter won't show. And the third position, the voltmeter will show and it can fire. And then the last 2 points here that we're interested in are these two right here. And that's where you connect the fire button to. So that is the MOSFET board. And you can check the wiring schematic for a little closer up view of this and everything, and where all the wires go. So I'm going to get some wire cut here, and most of this I'm just going to kind of offhandedly guess. Since we're building the 1590G, these don't have to be terribly long. I do make them a little bit longer when I'm just kind of off the cuff making a board. Just to make everything a little bit easier to get together. If you didn't notice before, these were kind of sitting off to the side. This is an automatic wire stripper. And if you strip a lot of wire, man, are these useful. They're about 20 bucks on Amazon, just automatic wire stripper. Apparently some electricians don't like these because they think they're unmanly or something, but if you look at what I just did there, I think they explain their own value. Alright, so I just dabbed some flux on the end of this wire, and we're going to do two things here. So we're going to pull up, and I'm actually going to intentionally fill in that hole right here for the bat negative. And hopefully this doesn't move around too much on camera. So I'm just going to reflow all this solder together and make sure it touches the three contacts on each MOSFET. Now notice the right hand leg on each of the MOSFETs here. So I just reflowed this area all together with solder, and then there's these little legs, the right hand of 4, and those have to be separate. Those are the gates for the MOSFETs, and those are what control the flow of electricity through them. So we want to leave those unhindered. Now that I have that all kind of gooped up and together, what I'm going to do is heat that up again, and right where that hole is, pass the wire through. And I found this to be the best way to kind of do this all. Provided you can get it through the hole. That's what she said. And apparently I can't. So there's a rule when you're making videos that it's pretty much Murphy's Law. And of course now the wire's getting hot. I swear to God, I made 10 of these the other day and I did not have this issue. Alright, the hole is right there. There. Alright, I'm going to let that solidify. And I'll show you the other side here. So that made a pretty good connection. I'm just going to grab the wire here and throw some more solder onto that. There we go. Alright, so that's our battery negative connection. And hopefully the other one goes a little bit smoother. Again, I'm just going to reflow a bunch of solder all over this. Get a nice little pool right across there. And you don't want to do these at the same time because then the MOSFETs will disconnect and that's bad. So again, we'll grab our wire and hopefully this one goes a little bit smoother. There's like one of those stray. So I probably should have like twisted or tinned this first. So we'll do that real quick. Alright, all happy and tinned. And now it will cooperate. There we go. Flip that around again. And just clean up the solder a little bit. Mostly just trying to make sure it gets across all that pad. But all the load is going to be traveling on the other side, so I don't have to worry too much. Alright, we'll let that in cool down for a little bit. And we're going to use some of this 22 gauge wire. This stuff. And we're going to attach that to this BAT Plus pad, or hole, or however you want to think of it. And this one is what controls the gates, like I said before. So I'm mostly just going to jab that on. Again, I'm sure there's those that would disagree with my soldering methods, but that's okay. If you're going to do the voltmeter, you might want to just solder on leads now, because when we get all the wires attached to this, we're going to heat shrink it up, and that way you can just kind of splice the voltmeter wires onto it, or you can solder those wires onto the voltmeter. These particular model are, this is actually one of the reasons I chose these to sell. They have these very accessible solder pads on the back of the voltmeter, so you can get at those real easy, and you can just take those wires off if you want to. Alright, now let's do the button, which means we're going to need a little bit more black wire. Doesn't actually have to be a different color, but it helps. And some red wire. Now these you kind of want to be a little bit long, because we're going to have to, this button doesn't have screw down terminals. Let me get this in frame. So we're going to actually have to solder these together after the wires are run through the box. So if it can reach out the whole of the box, it's kind of helpful. So these are, I don't know, it's really zoomed in right now. These are kind of long, definitely longer than they need to be. The button pads, buttonholes are labeled negative and positive. Doesn't really matter. They're just going to the same switch. And we'll move that. I believe the negative is on the right side in this view. I'm just going to dab a little flux on there, thread it through, and solder that in place. And I'll do the same with the red wire. Dink. There we go. Alright, so our board is actually all soldered up at this point. This is one of the points where how you build this might differentiate. For this build, I'm actually going to be putting the battery sled in series. So one battery will be connected to the other. And that means we have to route the negative battery wire a little bit differently. But if you were doing these in parallel, you'd have the two negatives connected together, and then this negative battery wire coming back to the back here. And then you'd have the two positives connected together and a positive wire running to the 510 connector. So instead, we're going to jump it at the back here, and since the battery sled says it that way, we're going to put the negative here and the positive. Actually, I usually do the positive on the left and the negative on the right. So that means both of these negative wires need to lead up to the front of the box mod, kind of like it's going to end up sitting along here on the side. That means we got to bend these wires over a little bit. And we just want to conserve a little space here. And we're also going to channel the button wires and this extra positive all out, so it's on a neat little package like that. So I got that all kind of put together. Then I'm going to trim off these excess wires at the back. If you end up with a bunch of kind of sharp pointy areas back here, you'll probably want to take a file or some sandpaper to it. We don't want those coming in contact with the box, which would be bad. If you do that, just be careful to not scuff up the traces on the back. So there's that. Next up. Alright, so we have this heat shrink tubing that came in the kit. And I'm just going to straighten that up a little. Close enough. Thread the whole board and everything into that. It'll be a little tight, but that's good. We're actually going to fully cover up the switch here. And I'm going to hit it with a heat gun. Also something I always forget to note. Heat gun is very helpful. Don't use a lighter. Use a hair dryer if you don't have a heat gun. Alright, and just to make it look a little nice, we can crimp that end there and straighten it up. So we have this nice little package, and then once this cools down and hardens a bit, I'll take an X-Acto knife and cut out the little switch area. So that is our MOSFET package, and that is a ton easier to do. Don't have to futz around with a resistor or the MOSFETs or laying them together or getting things to stick together, just some wire on it. So next up, we will kind of tear into the battery sled a little bit. Alright, let's talk about the battery sled. But before I do that, I'm going to throw some tape on this box just to keep it pretty. This is just painter's tape. Really useful to have a roll of this stuff around, especially if you're working on anything other than the plain old black boxes. Those are pretty tough. But anything with like a clear coat on it like this, you can scratch it up pretty easy with all the aluminum shavings laying around and dust and everything. So there's that. Alright, so we got a battery sled, and let's grab our 510 connector here, just get a layout of the land. So that comes up pretty close as it is. And then we have our button, and you'll notice the button is kind of sticking into where we want the battery sled to go. and all that jazz. If you've watched my previous video on building one of these with the old style MOSFETs, with these puppies, then you know generally what I like to do here is just shave down some of the battery sleds so I can get it to fit back in here a little bit, and we'll take a chunk out of that. Your other option is to remove this post right here, and this is especially a good idea if you're trying to fit a voltmeter in. Usually the voltmeter ends up right about here, and you just need that little extra bit of space to get it back and kind of sunk down in there a little bit. The only thing I'd warn you about with that is if you're jumping these two battery contacts, is you do not want that to come in contact with the box. So you're going to want to adequately insulate that, whether with epoxy or a thin piece of plastic or whatever. So basically what we're going to do is I'm going to take that burr that I showed earlier and grind off a little bit of area on these two corners so it fits back in here just a little bit. And I'm also going to kind of make a notch for the button to sit in right up here, and that will be probably the least amount of work to get this where we want it. Before I do all that, I'm going to pull out the battery contacts and we'll get started. One thing, these battery sleds, they're meant to be mounted on like a circuit board or something, so they have these snap-in things on the bottom. I just trim those off, and I usually take a knife to them, just plane them out a little bit. That'll be important later when we try to epoxy this into the box, so we can get a nice flat area, and you can kind of score that up too if you want to. Alright, so let's see, safety glasses and Dremel. I'll try not to make too much of a mess of my workspace here. Alright, let's see where that got us. Trim up some of this gunk off the sides, rather than making a gigantic mess. So that is actually a pretty close fit. One thing we want to check is with the board here. Notice these wires are sticking out kind of far. So squeeze those back in there a little bit. One thing we can do is trim off these tabs. These are for retaining the batteries, and I'm just going to score them with a knife. There we go. And they should just break off. Where'd my pliers go? Right there. So snap these off. And that's my dehumidifier. Hang on. Alright, so snap that off. Yeah, it's still a little tight. So we might need to slim down the sled a little bit. I haven't built one of these in a while, so you have to forgive me. So I'm going to take this out to my belt sander real quick off camera. What I'm going to do is slim down one of these sides, possibly both of them, and that'll give a little bit of extra room here, and that should be enough for what we need. Again, you could do that with this thing. It just takes a while, it makes a lot of noise. Or you could use sandpaper or a file, just anything to kind of grind it down a little bit. So I'll be right back. Okay, so apparently I lost the last shot that I took, which is kind of annoying. Came back in from the belt sander, just trimmed off the edges of that, and really don't want to show all of that again. Ground down a little bit more on this side so it fits back in there like that. So this is flush up against the wall and against this screw post here. And the button pretty much clears right here. I think you could remove a little bit like I did here, just to kind of carve it out a little bit, but that may not even be entirely necessary. It also depends on where your buttonhole ends up. So that'll work, and the whole MOSFET package fits in there now without any real problem with the button. So I don't think that's going to be an issue. The other thing I lost was grinding down the battery contacts. I had pulled these out here. So I guess I can do another shot here. So two things we got to do to these contacts. We have to shorten them up, and you can kind of see here. So these are nearly level, and the one on the right is just a little bit longer. So I use the grinder to shorten it down a little bit, break off that tab, and then the other thing is bending the tab in just a little bit, like the one on the top there. So the one on the bottom is unmodified, and we just use a pair of pliers to bend that. So grind down the tab just like a millimeter or two, and try to leave these little flared up parts intact, because they're what catch on to the battery sled and hold the battery contact in. And then when you get that all done, there is this gap between the battery contact. I can throw one of these in here just to demonstrate. So that little pointed end sticks out, and that's still pretty close to the bottom of the box, and we don't want it to short out on anything. So just grind them down a little bit further just to make sure. And that's about that. Next, we'll start soldering everything together. Alright, before we get any further here, let's expose the lockout switch. So the way I do this is just with an X-Acto knife, and it's already in the far position on this side. So I'm just going to stick the blade in and let it cut through. And then it's about there, I think, that it ends. So I'll make another cross-section cut. And we can just connect them together. And voila! And you got everything else insulated, but you got the buttons free to move. So that'll be helpful. Alright, now we have to start fitting everything in the box. First thing we should probably do is bridge this connection here, which is pretty easy to do. You're going to want a piece of your thick gauge wire, so we're using a thick 16 here. And I usually do about a little bit more than the width of the sled, just as a measuring guide. And I'm going to strip that off. Now, one of the tricks I found to soldering these sleds is these contacts aren't really entirely friendly for all the soldering and everything. I don't know why it is, solder just doesn't stick to them very well. So I've come up with a rather simple process, I feel. And I'm just getting a bit of flux here off camera already. So I start with dabbing a little bit of flux onto the battery contact and making a mess all over the sled. I don't know if this is entirely necessary because we're using rosin core solder, but I think it helps. And then we're going to form a bead of solder on the contact. And that's just pulling it up like this. And I do put kind of an excessive amount on it, but whatever. And then I'm going to dip the stripped end that we got in the flux and solder that down. Get a little bit of solder on the iron, and I'm actually going out the bottom this time. Found this kind of makes like a neat connection. So I got a good connection there now, and then while the the insulation's still pretty warm, I like to bend it over here. And there's like these teeth on my wire strippers, and right at the battery contact I kind of put a mark on it there and cut off, leaving a little bit of tail. And then I just strip it right at that mark I made, which is quite a bit there. So I'm just going to twist that up, make sure it's nice and dense, and then bend it and try to keep it together. Part of the problem here is I'm trying to do this so the camera can see. Normally I would pretty much have my head over this, but then you wouldn't be able to see. Okay, so here's where the forceps come in. I always forget to list all these tools. And just get a nice gob of flux on there. That's probably way too much. But whatever. And get some solder on the iron. And tack that down real good. And there we go. So this is our series again. This is going to bridge the negative of one battery, or rather the positive of one, or which way we're going to go here. So negative, positive, negative, positive. So positive to negative. And I'm going to avoid touching those right now because they're very hot. And we can check the clearance in the box. Nothing's going to short out on us, we can see that. And that, quite a bit of the work right there. Next up, let's start getting this package in here. Now, if you're doing the voltmeter, you got to be a little bit more careful with this placement and everything. If you're not, a little bit of slack here isn't a bad thing. I usually end up putting this so it's about the middle of the sled, and then we can start measuring where everything needs to go from there. So the reason I keep debating on which end is going to be the positive and which one's going to be the negative is because of the 510 connector. Now if we put the positive coming out here and try to get it to the 510 connector, that is going to be a very kind of cramped connection, and it'll be really hard to make. But if we just extend it a little bit further to this one, it's kind of a non-standard battery configuration, but it's easier to build, so there's that. So I'm going to do it that way. So let's see here. Our battery connection is this lower one. We can see it goes back to the middle of the board here. And this one is the one that goes to the 510. Black wire is obviously the switch button, and just gonna guess here, this is why we should have marked it. I think this red one it runs back to the positive, so I'm gonna get a Sharpie, and this is probably a step we should have done before, but just mark that. And I'm sure if I go back and watch the video, I could see, but it's doubtful you'll be recording this for yourself. Alright, so as far as our wiring goes, this one is the 510, so this one has to snake. This is the battery. This has to make it all the way back here. And we can rough approximate and trim that off. And let's see here. This the longer one is the one I just put the mark on. And that one needs to go to the positive pole. So I'm just trying to get like a rough measurement here of what that needs to be. It's okay if it's a little longer. I'll just trim that off though. And the 510 connector needs to make it all the way to the hole here. So I usually try to like stretch it out and get it there, and then trim it off right at the hole. Maybe give it a little extra. So that does it for most of our wires. We'll worry about the fire button when we get to that bridge. And just trim those off. Now we need to strip these down a bit and put kind of a long tail on that one. 510 connector, let's say you probably need like maybe 1/4 of an inch bared, not too much, which I'll explain in a minute. This one is our positive wire. So we'll bear quite a bit of that one. And we'll get these connected. Same process as before. I'm going to do the negative here first. And we'll set it up with a blob of solder for the positive. There we go. Get our, so our negative one is the negative battery lead is the longer one here. I'm just going to put a little flux on that. gonna try to tag it down so it comes out the bottom here, but I don't actually want any of the bare metal getting to the bottom of the sled because we don't want it to short out. It is a good idea to wait until the solder solidifies. There we go. Just going to wipe a little bit of flux onto this positive wire and get that tacked in place. Remember, we still have to connect the positive 510 connector wire to this. So I try to place it over to the side a little bit. And that should be good. Now if we did that right, well, that's not supposed to happen. The battery contact came out there. Nothing actually broke. So try not to touch that because it's going to be a little warm. I just want to bend that over so it doesn't hang down too much. And that is kind of our package, which should fit perfectly in here now. Next up, we have our 510 connector. Where that disappeared to. So what I've already taken off of it is this negative ground ring and the nut. And we're going to solder that other large black wire to this. There's not too much to these 510 connectors anymore. Dennis at Fat Daddy Vapes has done a pretty good job at simplifying them. Right now I'm just pulling out the positive core. And when you solder this, you do want to remove it from this dowel ring because you can melt that actually. And I'm just going to put that aside for the moment. And I'm going to put this in an alligator clip here. And the best trick I found for these so far is just get a little bit of flux and wipe it on here. Make sure you try to get some of that hole that's in there. And that should be about perfect. So I just load up my soldering iron with solder and tack that right down. Now I said you don't want to make this bared end too long, and there's a reason for that. When you screw down the 510 connector, you want to have a little bit of room for this nut to sit. So if that wire extends all the way to that inner circle, you're going to have trouble screwing that down. So that's that. Next up, we have the positive core for the 510 connector. This is also where you would attach the fuses, which is something that I hate doing. So here's our little 15 amp fuses. And this is always kind of a problem. These things are very delicate. Now you might ask why would you choose these tiny ass little fuses? Because the option is 2 of these. And that's about 1 inch square and will never fit in the box. So that's why we go with the really tiny ones. These are not entirely necessary. They are just a safety precaution. If you want to leave them out, I'm not going to tell the box mod police. I generally don't build with them, but since I include them in the kit, I will show you how to do it here. So we're going to get some red 16 gauge wire going here. And the trick to all of this is going to be making this very, very, very short. So I'm just going to start out with a little bit. I'm going to bare probably a bit more than 1/4 inch there. The whole idea that I like to use for this is when you put this wire into the 510 connector, there's that little bit of a gap right there where it sticks out, and that's where I like to apply the solder at. So again, not too much trick to soldering these. I just take a little bit of flux and wipe it around in the hole of the 510 connector. You do want to be slightly careful. If you slop around the solder and you end up soldering the center pin to this outside ring, you will no longer have a spring-loaded 510 connector. It will freeze it in place, and it's very unlikely that you'll ever get it undone again, so don't do that. With this method, I don't think I've ever done that, so I'm just going to put the wire in and clamp it in place. And then I just warm this up and keep applying solder until I get a nice little cone. So what this is doing is heating up all that flux that we put in there, and it'll boil out. And it kind of sucks the solder in. And let that cool for just a second. That will be very hot. And that is how you solder the 510 on. Looks like a pretty good job there. Let me see if I can get the camera to focus. So we got solid solder connection all the way around, and that little bit of bared solder right there will cover up a little bit of heat shrink tubing in a bit. Now here's the trick. Getting the 510 connector and these fuses, it's still kind of hot, to fit in here with the battery sled and all the other jazz. And those fuses is going to be really the problem. So one thing I do is bend this wire off at a right angle, hopefully without pulling too much of the insulation off. Alright, so we have to make it from, ignore that for a moment, to make it from the 510 connector over to this pad here. And we want to somehow attach those fuses in such a manner that they do not break off, which is probably easier said than done, because the fuses are about the length of that distance. Like I said, my most unfavorite part of these. If you could get these, easier to do. So keep that in mind. If you want an easier build, get the 1590B. Probably the simplest thing to do here is actually try to bunch this wire up a bit. I think what I want to do is I'm going to start off by soldering these fuses together, and I think they do have a bit of a direction. The only thing I'm going to try to do here is get them going in the same direction. I don't think it actually matters for the load. So to do that, I'm just going to wipe a bit of flux on each side. through that clamp. Basically just tinning these up. Now that puppy's going to be hot for a minute there. Clamp those back together and get that solder to go all the way. Okay, so now already we have a somewhat more resilient package. I think I'm going to try something new and just put that on the tail end of the 510 connector here and let that attach directly to the battery sled. Maybe that'll make everybody's life easier, who knows. Otherwise you can just say screw it and leave them out like I do. So I'm just going to trim that off a little bit. So it's now very, very, very short. And expose that. Consequently get flux all over my nice powder coated 510 connector. Alright, so let's see here. I think I want it oriented about like that. So I'm going to solder this on at a right angle. That gives us something like that. Honestly, this might be the worst idea in the world. Alright, where was I? Alright, so unscrew this thing. And we have a very jimmied together connection that I'm hoping isn't going to flex too much. Gonna trim that little bit off there, wherever that went. And I'll clamp that all up. So you can probably see why I like these pneumatic hydraulic arms or whatever they are. Alright, so that's roughly where I want that to go. Just to make sure we get a good connection here. Glob some flux on there. All right. Oh man. All right. Yeah, I'm not gonna make any guarantee that that's gonna work. But it kind of looks like it did. Seems pretty stiff as long as we don't screw with it too much. Those shouldn't break. So what do we got? So I got 2 button wires that'll go out this hole here. And then we can grab the 510 connector. I always like to take this plastic Delrin collet off. This insulates the positive from the negative. And I actually put that on here. Although I may come to regret that with this hack job on the fuses. First thing I like to do is get the 510 connector through the negative ring here, so that's on, and then get this nut started. Alright, so note I said just get it started. Then I like to bring the Delrin collar up and get that started into the 510 connector. And the only thing you really got to be careful about here is cross-threading this. The Delrin is pretty soft, so you don't want to mess up the threads on it. But you can kind of turn the 510 connector most of the way, and then you just sit here and crank on it. And that'll be pretty tight. And if you're using the regular low pro 510 connector, you can just take a quarter and tighten that up. With these bigger ones, I found I can mostly just hand tighten them, and they'll get to the point where they need to be. Now, what you want to do is take the nut from the button and thread it onto these wires, and then get these puppies to go out the hole. And get that all lined up. We can kind of hide that back in there. And just arrange these wires a little bit. Really trying not to break that off. Okay, last step other than gluing it all up is getting the button on. So we don't want to cut these wires too short because they have to come back in and be able to wrap around and still be connected to these contacts on the button. This isn't so much of an issue with like the chrome button that I have. This one has the screw-in contacts, a little bit easier to do. But we just have to solder up some stuff here with these. So I'm guessing you probably want maybe a little bit more than a finger's width of these wires sticking out. Trim that off. And I'll strip off just a little bit. Bang. And bang. And then you can take a piece of the heat shrink tubing and cut off a couple small dabbers. You gotta remember to put these on before you do the soldering. Otherwise you'll have to use some liquid electrical tape or whatever. And I'm just going to get a little flux on these contacts. Make sure everything sticks like it should. Now I have yet to find a good way to hold this button. I think that'll do. And you gotta hold the wire to it. There we go. Move the heat shrink tubing up. You want to make sure you get all of these contacts covered. Alright, so now we gotta kind of help these wires come back in here in a smooth transition so they don't break anything. Alright, that is in. So now I just gotta tighten this up. Alright, buttons in, good feel. Got our lockout switch down here. This should be a functional box mod. And I'll grab some batteries here. And an atomizer. Okay, so positive on that side, negative on that side. I swear these are married batteries, I just ran out of wraps. So there's that. And grab a little test thing I have. Or not. Alright, so we got the lockout switch in the off position. And it does not do anything, so that's good. Turn it on. And it works. So keep in mind that's with serial setup. As far as I know, these MOSFETs should be able to handle that just fine. Don't do anything super stupid. I think these are good down to about a 0.08 build. Going lower than that, you probably risk frying something out. And obviously if you use like some super high 35 amp discharge pulse batteries or something. Probably taking a little extra risk, but that is that. The only thing that we have left to do is get the lid on. So I'll kind of run through that real quick. We'll start with the grub screws. Now for the grub screws, you are going to need some sort of hex key. It's the only thing that fits in there. Sometimes powder coat does get down in these screw posts, so if you get the screws that came with the box, just screw one down in there with a Phillips screwdriver, and that'll clean it out. Otherwise, just be careful with these. I try to get them flush. I've seen other people leave them sticking up a little bit so the lid catches on it. I find you have to be too careful with the epoxy when you do the magnets when you do that, which I do not like. So get these in. Here I'm just turning it back and forth a couple of times. I think there's some powder coat in there. That should be good. One last one. And then I'll go over epoxying the magnets. Okay, cut here. Alright, let's talk epoxy. So what do I use? I use Bob Smith Industries 5-minute quick cure. I like this stuff, it's cheap, comes in big bottles, pretty good. If you don't want to go that route, you can get like DevCon. I like their 5-minute stuff. I am not a fan of Gorilla Glue. Your mileage may vary, but I don't like it. So you can use whatever epoxy you want, it doesn't particularly matter. If you're doing a lot of box mods, this Bob Smith stuff is pretty economical. For epoxy, I think we're going to need about a penny's worth of each part. And that will probably still be too much, but it's better to have too much. Which might also explain why I go through so much of this stuff. Though I have to say, these 2 bottles have lasted me about 8 months now, so there is that. And then we got a bunch of craft sticks here. I like these. It's like $3 for 1,000 of them. Mix up your epoxy. Now you may have noticed here in the bottom of the frame there are 4 black dots. Those are actually the magnets spread out right now. And there's a reason I do that. 5 minutes is plenty of time, but it does make it a lot easier to get these all in place. So I get this all mixed up and grab a new stick. Now, how much epoxy you use, kind of debatable. I go with pretty much that much on the end of it. It's really not a lot, and then you just kind of wipe it around inside the hole that we drilled earlier. You don't want it coming out the top, so don't put too much in. Otherwise your box will get all messy. And then I have this on a plate so I can sit here and turn it. So I just dab them all up at once. And then you're going to want a non-metallic stick, so another wood stick. And I use a screwdriver to pick up the magnet and place it down in the hole. And then push it off with the wooden stick. And you just want to make sure that's level. Sometimes they can get in there not perfectly level. And that was a mistake right there. So I got too close to the other magnet there, which was a mistake. And we'll do this one. Get that to come off. Push that one in. And there we go. Just set that off to the side to dry, and obviously I made too much epoxy there. If I was thinking ahead here, I could use that extra and glue in the battery sled right now. And we're just getting up to the end of the pot time on this stuff, so I just use a stick to kind of scoop it in underneath the battery sled. And just press it down flat. And if you want to, you can scoop out this extra stuff. If you get a lot of it in there, it will get in the way of your batteries, so that might be a good idea. Generally you want to avoid smearing this stuff. If you have large clumps of it left, like I just made a big mess right here on the sled, you'll be able to chip that off later with an X-Acto knife. So that's that. The only other thing to talk about or show would be grinding down the lip on the edge of the lid. So this is from another box mod. This is another SX350 that I built. And you can see pretty much we have the same problem of the button gets pretty close to the edge right here. So all I did was I took my Dremel and just ground down that lip right there, and that lets the box sit flush. So you might need to do that for the button and for where the 5-time connector is, because they're both pretty close, and I had to do that on both of these. So that's that. After the epoxy dries, you just trim off the extra any little bit that pushed through, like right here. I use my wire cutters actually, and that usually gets most of it, so you can just clip it off. And otherwise you can just take a utility knife to it and just be careful and scrape the rest of it off. And that's your box mod. Not that you can really see that, but let's just wrap this up here. This is the completed mod with all the tape taken off of it. Note my mutation V4 is very dinged up, so there's, you know, that nice looking thing on top of it. Inside looks pretty good. I just shaved off this lip here like I was talking about in the last clip, and everything fits great now. You can reach this button, or switch rather, pretty easily. And it fires up, that's for sure. I think in the long run, the fuse situation that I kind of hacked together there will work pretty well. And just give you a little demonstration. Let's say it works. So if you'd like to buy this kit, visit us at NONAMEBoxMods.com and look for the Dual 18650 kit if that's what you're interested in. I also have this in the 26650, and I think give you a little sneak preview of what's to come. This will be a 26650 squonk box, and I'll have something similar with a 18650 in the smaller 1590G box. So a little size comparison there. This works pretty good, gotta admit. I special ordered this Velocity RDA from, I think it was Fast Tech, and then got all the squonk bits in here from Fat Daddy Vapes, and just got the MOSFET board down here at the bottom. So if you're interested in that, be watching for the next build video.